What's up, ladies and gentlemen? I am Dylan, the TechnoGiz guy, and today things are getting a bit bright in here. So today what we are going to do is we are going to be setting up some WLED strips. What is special about these is they are WRGB, so you can get RGB out of them, but you can also get white out of them because they have a dedicated white LED on them. What is also nice is that these LEDs are addressable, so you can do a lot of cool things with them. To power these LEDs, you're going to need something like this and a power supply, and a little bit of wire and a little bit of time. This is a wiring and electronics video, guys, a little bit, as well as a Home Assistant type of thing. When we're done, these lights are going to integrate completely flawlessly with a Home Assistant setup. If you don't have Home Assistant set up, you can still use these lights. If you're worried that I said that this is an electrical project, don't be. Everything we're doing is super easy. I'm going to walk you guys through it, so just don't even stress it. So these are the LED strips that I got. These are the BTF lighting WLED strips, or WRGB, sorry. These are 5-volt LEDs, so I went with natural white, so if you look here, let me try to zoom in. So you get RGB, and then with these you pick a different white. So I picked natural white because I like natural white. But so yeah, these are not all that expensive actually. So I think these were like 20, 30 bucks. I bought 2 strips because this little controller is able to do 2 channels. Now let's talk about this little controller. So this little guy is made by a guy named QuinLED. I don't know if he goes by QuinLED or QuinLED, but he designs these boards, and basically these are power supplies as well as an ESP board. I believe it's an ESP32, and this will join a Wi-Fi network and then link to Home Assistant. And this is all completely open source, by the way, but you can build these yourself, but he sells them, pre-made like this. This is literally how it came. Comes with a little 10 amp fuse. You put power in over here. You get power out for your LEDs over here, as well as data. So here I'll show you. So you get LED channel 1, LED channel 2. You get a ground, you get a positive, and you get a GPIO. That is the data line that will tell your LED what color to be. Once you have this, you need a power supply. And that's what is in this white box. This is a 5-volt, 20 amp power supply. I bought this, it was recommended for the BTF strips. I think I got it recommended from this QuinLED guy. I may have found it on Amazon. Quite frankly, I can't remember. But it's a 5-volt, 20 amp power supply. This will take 110 volt or 220 volt and downstep it to 5-volt DC, and in theory give you a maximum of 20 amps. That may sound like a lot, and it is. For 5-volt, 20 amps is a lot. That is a lot of amps for low voltage kind of application. So let's just talk about why. So why do you need a 5-volt, 20 amp power supply? Well, one, these LEDs are 5-volt. If they were 12-volt or 24-volt, then you would want to get a 12 or 24-volt power supply. But you need 20 amps because with these controller boards, you can actually get really long strips, and through voltage injection, you can continue running the strips for very long lengths. The longer the length of the run, the more the current you're going to draw. So, yes, these LEDs by themselves do not draw a whole bunch of current. Once you run 2 of these 8-foot... Editor Dylan here. 5 meters is closer to 16 feet, not 8. Sorry. Runs off of these boards, you're pulling a good bit of current there. Let's get this power supply out of here. I have already opened all this and made sure it works, so hooray for me. First thing I'm going to tell you about this power supply. It looks impressive. It's not. It feels like a toy. The second thing I'm going to tell you is right here, everybody, there's a little switch in here. Now, you want to really be careful. Now, they do put a warning label telling you to check the switch. Read the warning label and see the switch. You see the switch? So you have to make sure that you set this to the right voltage. Because if this is set to 220, which by the way, it was set to 220 when I got this, and you're in North America, and you plug this in North America, and it's set to 220, it probably just won't do anything. But if it is set to 110, and you plug it into a 220 outlet, and you're, overseas, and you're using 220 and not 110, guess what? This thing is going to pop. It's going to pop real bad. I don't see any protection circuit on here. This is just a basic machine. On the front here, you have some screw terminals and a little tiny screw adjustment and an LED. What these are is, and they're labeled here, they're not labeled well, but it is etched into the metal. So these are your two AC terminals. The first two terminals are your AC terminals. You have your load and your neutral. You then have your ground. This is what you are going to run to your AC ground, which I will explain in a second. Then you have two voltage negatives. This is your DC negative, these two. Then you have two DC positives, these two. Then you have a voltage little adjustment. So this is a little Phillips screw, and you can adjust this up or down to modify the voltage. Why you would want to do that is over a longer length of LEDs, what is going to start as 5 volts is going to quickly become something like 4.7, maybe even 3 volts. It's called voltage drop. It occurs over long distances in wire. Well, to combat that, the two things you can do are increase the supply voltage a little bit, so that way the drop is not as bad towards the farther end. You can also do power injection, which you'll probably have to do anyway if your run is really long. Power injection is where you take another power lead and you run it directly to another point on your LED strip. You do that because the little tiny metal traces that are in these LED strips, and I'll take this out of the bag in a second and show you guys what they look like. The tiny little traces that are in here are not all that strong. So you don't want to just send a bunch of current through them because they won't be able to carry it. They're going to get a lot of resistance, and eventually you're going to get a bunch of voltage drop. So at certain points, if your run is really long, you are going to have to inject voltage onto the pads of the LEDs to make sure that the strip stays fully lit. With the QuinLED little board, this guy here, you get this little barrel plug to adapter. This makes it really easy because you can just wire this up and then just plug like a 5-volt barrel plug in here. I'm not using that. This might get used in the final deployment of this project, but for now, I just want to get this working for you guys. Now let's get into things you guys are going to need to make this work. So these are the things you have to buy. These are the things that you can probably source. You should probably have these things. So you need a little bit of wire. If you don't have some wire, you can use like speaker wire or something like that, or you can cut wire from an old electronics. You just need 2 conductor wire. If you are running a lot of current, like this is not the wire that I would use for something higher current. I'm doing it for the sake of this video because I'm only going to run a few of these LEDs. Once I go to fully deploy this LED solution, then I'm going to be using much thicker gauge, probably 18 gauge wire, not this real thin kind of basically speaker wire stuff. This is probably like 22 gauge, maybe 20 gauge here. For a testing type of purpose, it's fine, but even this adapter you can see that it came with, it has 18 gauge leads running into the adapter. So, like I said, this is not going to be a permanent solution. It will be fine for this video. The other thing you're going to need is an AC power cable. Now you can get these already pre-stripped. They sell them. The probably easier way to get one of these is to find a C13 power cable for a computer or a monitor or a power brick or anything like that. A lot of stuff uses those C13 power cables. You're going to take the computer or the device end, you're going to get a pair of wire strippers, and you're going to snip it off. Then you're going to really gently strip the wire sheathing around because the actual wires for these are inside. So these 3 colored wires are what is inside the rubber jacket. Now, don't worry, there's no power on this, so you can play with this and manipulate it. Little bit of lesson on AC. I don't do a whole lot of AC, but you do have to do it once in a while. In AC, it's a little different rules than we're used to in something like low voltage DC. Normally in DC, what you would do is you would have red be your positive and black be your negative. Unless you don't have red and black, if you have like white and green, you would do white as a positive, green as a negative. In AC, black is your negative, or black is technically your positive, white is technically your negative, and then green is ground. I say technically because AC works very differently than DC. Alternating current and direct current are very different things. I am not going to try to explain that in this video, but just understand they're different. If you already understand that, cool, skip all this. But anyway, basically, 2 of these are not acting like a positive and negative because the current is actually alternating between them. So the black in this case is actually a load or line sometimes. The white is a neutral. Then the green is your ground. So in AC, you do not have a positive and a negative. You have a load or line sometimes. You have a neutral and you have a ground. If this were 2-phase AC, it's essentially the same thing. You just have another neutral, or you have the same neutral and you have another hot. So you basically, this would be the same cable, but you would have another line wire. Sometimes you will hear this referred to, the black wire, as line. Sometimes you'll hear it referred to as load. Sometimes you'll hear it referred to as hot. It means all the same thing. Essentially, just think of it as, this is your, if you want to think about it, positive. I'm sure some electrical engineer is going to ream me out in the comments for saying positive and negative in regards to AC, but I'm trying to explain this to people who don't really know anything about electrical theory. So cut me a break here. But anyway, so yeah, black, white, green, load, neutral, ground. You don't always need a ground in AC, but you should do one when you can, because basically if lightning or any kind of electrostatic discharge occurs, the ground will keep you safe. The ground will keep you safe. It will keep a lot of your equipment safe. It's a good thing to ground when you can. Okay, so how do we wire this up? So we're going to flip this little protective cover. So here, when this is in operation, there's a little cover here, so that way you can't accidentally get to the screw terminals. We're going to flip this up. I would show you the engravings on here. I might try. I guess you can see those. You can see we're going to do black, white, green, and then we have our voltage negative and voltage positive for our DC. I've already measured this with a multimeter and set this to a level that I'm comfortable with, so I'm just going to throw these in. And all you got to do is unscrew these terminals, and you're just going to stick your wire in. If you stripped the wire yourself and you did not buy pre-cut wire that was already, cut and soldered, just give your wires a little bit of a twist before you put them in here, so that way they all stay together. And then you just want to screw these down, keep them nice and stable, and screw them down. Sorry guys, my hand's in the way. So you want to get these nice and tight, and we call it a tug test. The tug test in my line of work is when you tighten something down, you just want to give it a little tug. You're not pulling on it, you're just making sure that it's in there good, it's not going to come out. Put my ground in. That's the other reason you want to... So the couple reasons that you want to twist these. One, when you stick them in, you don't want them to like fray on you and go everywhere, because then they won't cooperate. Two, if you twist them together, you will actually get a higher surface contact overall with the terminal, which is important because the terminal is actually what supplies the voltage. Well, actually, the cable sends voltage from your wall into the terminal. So you want a lot of surface contact. So you want to kind of twist them together so that way they get really nice and compressed and there's a lot of surface area getting covered with those terminals. Two, you want to be careful so you can see kind of there that I did not all the way twist down this cable, and as I stuck it in, it tried to like fray. Luckily there's a wall divider there, but it could have jumped over and I would have had my ground shorted to my neutral, which when I plugged this in would have instantly popped my breaker and my breaker panel. So then we're just going to come in here. I'm going to use the innermost ones. Now we're going to go negative and then positive. So in this case, I'm going to take the black. Black is going to go first. Red is going to go second. Just going to stick those in there. Hold them in. And screw them down. Get nice and tight and tug test. Not going anywhere. We are done in this for now. Double check your work. We're done in this for now. Now we need to get this guy hooked up. So I actually need some of this wire for the LED strips. So I'm going to cut it right here. I'm going to use my pocket knife here. I'm going to just be really careful doing this, but I'm going to run it down the center of the two wires so that way I can break these apart and isolate them. Try not to cut your fingers off, guys. I am not going to be responsible if you cut your fingers off. That's why I say what I usually do is I just kind of skim the wire and then come down with my nails and just pull them apart. Once you have a little bit apart, grab your wire strippers and just strip the wire back. Don't need to do as much as that. That was actually a lot, but remember, give them a little twist. As soon as you strip any wire, you should just give it a little bit of a twist. It'll make it easier to solder. It'll make it easier to put into terminals. It's just a good idea. Just give it a couple turns, make it nice and tight. You're trying to make it like one solid wire without actually having to be a solid wire. Let's get this thing in here. So pay attention to your polarity. So this one says ground on the left here, and on the right it says 5 volt to 24 volt. So we're going to put our black in the one that says ground. I'm going to put the black in this one. Black goes first. With these connectors, these plastic screw down connectors, when you tighten them down, you want to get them tight, but also while you're tightening them, it's not uncommon for them to like twist and stuff because they're really not all that secure. Basically, that little screw terminal that I'm screwing into is held on with just the solder that is, holding these terminals to the board. So there we go. That's why.
Oh no! Oh no! No!
Paired up. Now we got to bring some LEDs out from this side to our LEDs, and we get to open our LEDs finally. Alright guys, we're just going to bring open the LEDs here. Ooh, they smell like China. China. Okay, so these actually came with wire pigtails on them, which is great. Alright guys, so I'm going to use this camera here to show this. But you can see that these LED strips they look nice. You can see that there's two distinct LEDs there. There's a color LED. Well, actually, there's a cell for multicolor, and then there's a white LED. You can see you have every so often you have these pads that say 5 volt, data, and ground. Where these pads are where you're able to cut. So every single one of these little pads has a little white dotted line going through it. And that's where you're able to cut this down to the size you need. You get these connectors. I forget what these are called, but I'll leave a link in the description. I have some of these. that plug into these and just give you wires out. Alright guys, so I'm going to strip this wire. I want to leave these connectors on. I do not actually have any of the LED connectors, which is fine. We can make do for now. Like I said, I'm just getting these set up today, and then the actual process will be later. So you have the connector, and then you have these. These wires are for injection, so I'm going to assume that I can just use them for injecting power. So in this case, the red is your positive and the white is your negative, and then green is your data. One of the little things. Oh crap! So to get this on, to get this in here, you actually have to pull the ESP board off of this. So we're going to pop that little fuse out, and then we're going to grab the ESP board and just real gently, real gently, just rock it out. Rock it out. Try not to bend any of the pins. Alright guys, get your wire in, screw it down, and you want to get these tight, but you don't want to like super wrench down these terminals because you will break these little screw terminals. I work with a guy who, he's a great guy, but he screws the terminals down too tight every time, and all of his stuff ends up breaking off eventually. Hold that down, screw this. So basically the way that this is set up is your outer two are your positive and negative. So you have your negative and we have our positive. And then your inner two are the two different data wires. So you'll send one data wire to one channel, one data wire to another channel. Now you're probably wondering, how am I going to do this without the right connector? Well, I'm going to cheat. See, I have these little jumper terminals and I'm going to stick it in the data pin like so. And then I'm just going to put this, cut this off and just put it in there. Okay guys, so I'm going to just cut this end off. Normally this is the female end. These are cheap, so I don't mind wasting one of these. A baggie of about 100 of these little connectors is, like I said, yes, you want to get this tight, but you don't want to get it too tight. When you're screwing it down, you use like, if your screwdriver spins at least, use like 2 fingers, and once your thumb and your ring finger start getting a little bit like, once you start feeling the torque in your thumb and ring finger, then just let it go. Everything is wired up and put back together. So now we should be able to plug the power supply in, and the LED should turn on.
Oh, you'd think so, wouldn't you?
Then we'll be able to set them up.
It was at this moment that he knew. He fucked up.
At least that fuse works. Okay guys, so let's talk for a second. Come here. So my other camera died, for one. Actually, the SD card's filled, and I don't know where my other one is. 2, I really hope I didn't just fry this board. I realized that I had my positive and my negative backwards. I went to go plug it in, and did nothing. I realized it kind of quickly, so I'm hoping it didn't do any damage. It did blow the fuse, so we know the fuse works. Hopefully it didn't blow everything else up. Let's find out. So I have my LED strip here. I'm going to plug in the power supply. Oh, there we go. Look at that. So only about the first, I think, 30 LEDs are lit up. Or like, maybe like 10, 20. No, that's 30. Yeah, so only like the first 30 are lit up right now. But that's normal. That's fine. So let's look. See, it just stops. So that's normal. So now these are going to make a Wi-Fi network. I'm going to come up here to Wi-Fi. So you're going to come try to connect to this, and the password is going to be WLED 1234. Once you get connected, it's going to have you sign in. This is not actually a sign-in. This is a really clever way of using the captive portal on access points. So I'm going to do Wi-Fi settings. I'm going to scan my network here. Basically, they're utilizing the captive portal within a Wi-Fi access point to allow you to set this up. And it's really nice and it's a smart use. So let me type this password in and get back with you. Okay, so I saved that. This is going to reboot and join my Wi-Fi. Now that the LEDs are on my network, you should see them in Home Assistant. New devices have been discovered 33 seconds ago. Hey, look at that. WLED has been discovered. Gonna add it, and that's it. It's in. It now works with Home Assistant. Okay, hang on. We got to fix a couple things. So within Home Assistant, you can click this visit link, and it will bring you here. And this is where you can kind of configure some things. So I go to LED preferences. So then when you're up here, you're going to want to pick your LED strip. So the ones I have are the SK6812 RGBWs. If you don't know which ones you got when you bought your LED strips, it says it on the sticker. For now, I'm going to set up my channel 2 as the exact same thing because I have the exact same set of LEDs to put into channel 2. And I'm just going to save this. Ooh. Okay, cool. Let me grab the camera. So setting that did, in fact, set more of the LEDs to being on, but it did not set all of them. So what I'm going to have to do is figure out what distance I have to type in to get the whole strip to light up. So what I'm planning to do with the two different channels is one channel is going to go around my desk and then under the desk to give like an underglow. And then the second channel is going to go around my two monitors that I have. And I think it'll look really cool. I'll be able to control them independently. They'll probably be set to the same color most of the time, but whatever. Alright guys, so I was playing with it. I still don't have all the LEDs on, but I have it set to 220 on the channel. So that's 220 LEDs. I could do the math and figure out how many LEDs are on this roll, but I just don't feel like it. So yeah, you can see they're on pretty much all the way to here. And then, which is fine. That might actually be enough to cover it. I can turn more on. I can keep increasing this. You guys can see I'm going to set the lights to like a purple. You guys can see when I click it and when it changes, it's so fast. Okay, what about Home Assistant? Surely Home Assistant isn't going to be that fast, right? It is. It absolutely is. Blazing fast. What if I want to turn them down? Let's go down to 3%. Let's go up to 100%. Turn them off. You can do cool things like effects. So I can do like that. And you'll see the effects are going through. And you can do all kinds of different effects. Alright guys, that's it for this video. I am not going to show you guys me installing them in this video, but I wanted to show you guys the product. I do have another kit. Now, I want to point something out. Make sure if you want to do a lot of LEDs that you get a power supply big enough. So if I come in here to the LED preferences mode, so assuming that channel 1 is 220 LEDs and channel 2 is 1 LED, they're telling me that at 5 volts, I will need 13 amps maximum. So, and by the way, mind you, my LEDs are not all on yet. So if I get down to it and I have to increase more of these, plus I still have to account for the other channel for the back of the monitors, I may still need a bigger power supply. I don't think I will. I think I should be fine. I'm going to actually measure this with a multimeter to be safe, and you should as well. If you don't have a multimeter, you should get one. So if you want to build this, you can. It's a DIY. It's easy to do. I will leave all the links down in the description. This is a really good gateway into electronics. So some things you want to pick up if you don't have them: a screwdriver, a pair of wire strippers, and some wire, and a multimeter. You can go down to Home Depot right now and get all 3 of those things for probably $40 total. There's all kinds of different effects and colors, and of course you can do white, which is really cool. Basically, you get to choose between like daylight white, pure white, or like off-white or something like that, whatever it is. But yeah, check these out if you want some smart LEDs that are completely open source. By the way, because they are local and they're not going and reaching out to the cloud, these will still work when the internet goes out. So even though they rely on Wi-Fi, as long as your Wi-Fi network is up, they will work, even if you don't have internet connection. That's really great. Anyway, guys, thanks for watching this video. If you enjoyed the video, please leave a like. If you're new to the channel, please subscribe. Comment down below if you want to see anything or if you have any ideas you want to share. Guys, I'm serious. Comment, like, share the videos. It helps a lot. If you guys like the content, please share it, like it. It helps a lot. YouTube seems to throw me curveballs up and down, and I still don't know what to make of it. But we're getting there. I'll see you in the next one. Thank you for watching. And thanks for being here.